Yeah, hi friends, welcome to AIMS Today YouTube channel. In this video, we are going to discuss about AIMS India live sessions from that language of chemistry, which is generally useful for all the classes. Especially we have planned this for ninth class students from the chemistry subject. In this, we are going to see first about introduction of the language of chemistry and a few points about valency also. Chemistry is a branch of science which deals with the study of chemical substances and their composition and their properties. Means, so in chemistry, we are going to learn about the different chemical type substances and their composition and the properties of those chemical substances with which these are made up of, what are the elements present in this composition. These all we are going to learn in chemistry. To make it easy and systematic study of subject, chemistry is subdivided into various branches. So some of the branches of chemistry, as we have known, we might have known. One of them is we say inorganic chemistry, which deals with the extraction and metallurgy of the different elements. Organic chemistry, which deals with the study of carbon and its compounds. Physical chemistry, which deals with the different kinds of uh, what we can say qualitative analysis. Analytical chemistry, the composition research. Industrial chemistry, the manufacturing studies we are going to learn in industrial chemistry. Nuclear chemistry, the nuclear reactions, how they are occurring. The study of nuclear reactions we see in nuclear chemistry. Biochemistry, living thing related chemistry we learn in biochemistry. Nanochemistry, the microparticle research we study in nanochemistry. So these are the different types of subdivisions in the chemistry. From each, we are going to learn in different ways the chemistry. Now, chemistry and its language. Is chemistry having a language? Is it a subject to learn? Of course, it is having. Because when you start learning a language, what do we do? First, we learn the alphabets in that language. Suppose if you say it is English, you start learning English. I think you would be remembering this. When you start joining the school, you will be starting learning that language of English by learning from alphabets of it, like ABCDs. And then we start with simple words. And then, after writing these words, finally, we form sentences with these words. So in this way, we start learning a language. First, we learn the simple words of that language. Simple letters or alphabets of that language. By using these alphabets, we frame words, simple words first. By using these words, we create a sentence. In this way, we start learning a language. In the same way, similarly, while learning chemistry also, we start by learning symbols in the chemistry. Symbols of the elements, and then by using these symbols we start writing formula of the compounds, and by using this formula of the compounds we start writing chemical equations for the reactions. So in this way, chemistry also having its own language. In this language, just like in the other languages how we learn starting by using alphabets, here we start learning chemistry by using symbols of the elements. And then there in the different languages we start using these alphabets to form words. Here in the chemistry, by using these symbols of the elements, we write molecular formulae of the compounds. And then in the other languages, by using these words we frame different sentences. In the chemistry, by using these chemical compounds formulae, we start writing chemical equations for the different reactions. In this way, chemistry also having its own language. About that language, we are starting learning here. First, as we said, the learning of chemistry will be started with symbols. So, what is this symbol here? We use many symbols in mathematics to avoid writing full and lengthy terms so as to save time. We know suppose 2 plus 4, if you want to write 2 added to 4, their addition or added to can be simplified by using a simple symbol plus. So this plus makes us a simplification. Just this indicates addition. If you write this in between any two numbers, it indicates addition of those two numbers. So if you write subtraction, it makes that simplification that subtracting one two from other. In this way, these are all the different symbols used in mathematics to make it convenient and save the time. Instead of writing lengthy words, it is just by using a simple symbol, we are making it easy. In the same way, a stenographer uses shorthand to save time in taking down notes. So we might have known about stenographers while telling some sentences or some notes. They use some shortcut notes, shortcut words for writing, shortcut codes for writing these notes. Just by simply giving codes, they can write complete sentence or paragraph given there. So, but symbols of these stenograph are totally different from the symbols we use in mathematics or chemistry. They're having their own shortcuts. So here, by coming to chemistry, the need of symbols also felt by chemists as science advanced. So as chemistry is being advanced, scientists felt that it is convenient to use some shortcut methods for representing elements that led to discovery or giving these symbols for the elements. In chemistry, a symbol is defined as the shorthand sign for the full name of an element. To simply say, the shorthand notation of an element's name is known as symbol for it. J.J. Berzelius suggested a method of representing elements using English capital letters. So he was a person who given the ways for giving symbols for the elements. J.J. Berzelius, he started giving symbols for the elements by giving some peculiar rules for giving those. Not only he, before him also they have used some different symbols for denoting these elements, representing these elements. But at that time came to know very few number of elements. But as the number of elements being increased, as science being advanced, the remembrance of these symbols, the elements by using those symbols made difficult. That's why they have turned up to Berzelius method. J.J. Berzelius have given some ways for giving symbols for the elements. He has given some symbols already exist for the existing elements. He has given some peculiar rules for giving symbols for the upcoming elements also. Those are the starting letter of an element is used as symbol for that element. Is one rule. One point from his instructions given for the symbols writing. Second one, if already this first letter is existing as symbol for some other element, I think is it clear to you? The first letter of an element is taken as its a symbol and it is written in the capital letter. If this first letter is already existing as symbol for some other element already, then one more letter along with this first letter, that is generally said the second prominent letter also is taken into its symbol. For example, H is a symbol of hydrogen and Mg is a symbol of magnesium. In the name of magnesium, M is the starting letter of many other elements also. So to avoid the confusion, along with M, the second prominent letter G also taken into its symbol. So Mg is a symbol of magnesium. In this way, by giving some peculiar rules for writing symbols, J.J. Berzelius represented elements by using symbols. Each element has an unique symbol assigned to it. No two elements are having same symbol. For every element, different symbol and unique symbol is given for it. The symbol of an element is not used for any other element. As I said already, only one element is having one symbol. And the symbol of an element is not at all used for any other element. Every element is having its unique symbol for it. We have seen that there are around 180 elements are known presently. Each of these elements have a symbol for its own. For example, the symbol or shorthand representation of element hydrogen is H, because as I said, the precautions taken while writing the symbols or the rules followed while writing the symbols, the first letter of the name of that element is taken as its symbol. So in the name of hydrogen, the first letter is H, so its symbol is taken as H. We may know the name helium, second element. For this element, also the first letter is H. So already H is taken as a symbol for hydrogen. So to avoid the confusion for helium name symbol, along with the first letter H, second prominent letter also taken into its symbol. That is He. He is a symbol of helium now. In that way, symbols are derived from the elements. These are just shortcuts, we can say simply, or shorthand notations of the elements' names to make it easy and convenient and to save the time. These symbols are generated. The symbol or short form representation of the element oxygen is O. As we know, the name of the element oxygen, from this, the first letter is O. So it is taken as its symbol. In chemical changes, when we write oxygen O, it means the element oxygen. So to make it convenient in writing the chemical reactions and equations, instead of writing complete oxygen, just by writing O, it represents the element oxygen. In this way, it is made easy writing chemical reactions and equations by using these symbols of the elements. Some elements are having their symbols from their Latin names. For example, element sodium has its symbol as Na, because its Latin name is natrium. So from the name natrium, the starting letter N is taken, but N is already there as a symbol for some other elements like nitrogen. So along with this first letter, second prominent letter also is taken into its symbol Na. So in this way, not only sodium, some other elements also, like around 11 elements are there. Those elements are having their symbols from their Latin names. We know potassium. Potassium is having symbol K, because its Latin name is kalium. From the name kalium, the first letter K is taken as symbol for potassium. And we can say iron. Iron is having symbol, as you know, Fe, because the Latin name for iron is ferrum, Fe. And next we can say copper, cuprum, Cu, and lead, Pb, plumbum, mercury, Hg. In this way, around 11 elements are there which are having their symbols from their Latin names. We have to know this point here. Before Berzelius also, scientists proposed many systems to represent the elements, but they were failed because it was found difficult to use those symbols. Even Dalton proposed some symbols for the elements by using some circles, plus in them, minus in them, some dots. In this way, even Dalton also proposed some symbols for the elements. Not only Dalton, many they have come with their proposals. At that time, they came to know very few number of elements. They have tried to remember by using the symbols at that time. But later on, as the number of elements being increased, the discovery of elements becoming more, the remembrance of the elements by using those symbols became very difficult. So they have turned up to Berzelius symbols. At present, now we are following the Berzelius method for representing elements by using shorthand notations called symbols. Next, one more important point, atomicity of the elements. The number of atoms present in one molecule of an element is called its atomicity. Based on the atomicity, the elements can be classified into different types. So, the number of atoms existing in one molecule of an element is called its atomicity. So, based upon the number of atoms existing in its molecules, all the elements are categorized into different types. Let us see those one by one here. First among them is monoatomic elements. In the name itself, it is there. Mono means a single. The elements with only one atom in their molecules are called as monoatomic elements. The molecules of elements, they have only one atom in it, then they are called monoatomic elements. You can say here some examples: neon, Not only neon, mostly all noble gases are monoatomic elements, because these noble gases, as we know, inreactive or least reactive. They won't combine themselves and they won't combine with other elements also. That's why they will be always existing in the form of single atoms, single atomic gases. So they are monatomic in nature, and mostly metals also, like copper, gold, iron. These all metallic elements also come under monoatomic elements. Next one, diatomic elements. The elements with the two atoms in their molecules are called as diatomic elements. Means if the molecule has two atoms in it, then that is called diatomic element. Examples are given here: hydrogen, oxygen, chlorine. Most of the non-metals, they exist in the form of diatomic gases. Hydrogen is a diatomic gas because in molecule of hydrogen there are two hydrogen atoms. Even oxygen also having two oxygen atoms. Chlorine molecule also having two atoms of chlorine. So these all come under diatomic elements. Next we can say triatomic. So tri represents, as we know, three. The elements with three atoms in their molecules are called as triatomic elements. Example, very familiar one, ozone. I hope you know about the ozone. Where does it exist? Yes, ozone exists in troposphere. What is the purpose of this ozone? As we know, this ozone protects us from harmful radiations like UV radiation and alpha, beta, gamma radiation. These all harmful radiations are being filtered by this ozone layer present in stratosphere. So here the point is, in ozone molecule, three oxygen atoms are combined together to form a single molecule. So as the number of atoms 3 in the molecule, it is known as triatomic element or triatomic molecule. Next, polyatomic elements. So generally, the elements with two or more than two atoms in their molecules are called as polyatomic elements. Here, poly represents many. As you know, poly represents many. So the elements with more than two atoms in their molecules are known as polyatomic elements. Here some examples are also given. Phosphorus. Phosphorus is a tetraatomic element because in phosphorus four atoms are combined together to form one molecule of phosphorus. In the same way, sulfur, we can see here 8 atoms of sulfur are combined together to form one molecule of sulfur. So we can say sulfur is octaatomic element. So these all come under polyatomic elements. So in this way, the number of atoms existing in one molecule of an element is called atomicity of that element. Based upon the atomicity, all the elements are categorized like this into different types. Next, valency. During the formation of molecules of compounds, atoms combine in certain fixed proportions. This is because of the fact that atoms have different combining capacities. Here, this combining capacity of an element is called as valency. So as we know, different compounds are formed from elements. So these combinations are different in different compounds. That depends. This formation of a compound depends upon the combining capacity of an element. This combining capacity of an element is known as its valency. Yeah, of course, we are going to learn later. This valency can be defined as the number of electrons lost, or the number of electrons gained, or the number of electrons shared by an element to become stable or to form a compound by other element by combining with other atoms is called its valency. To say simply, the combining capacity of an element is known as its valency. Valency is measured in terms of hydrogen atoms or oxygen atoms, even in terms of chlorine atoms also. The valency of hydrogen is taken as 1 and it is selected as a standard valency. So, by taking the valency of hydrogen as standard, the valencies of remaining elements are compared and calculated. when it is combined with hydrogen, its valency is calculated. So let us see how it is done. The valency of an element can be also be defined as the number of hydrogen atoms with which combine with an atom of it. So when hydrogen combines with other elements to form compounds, the number of hydrogen atoms combining with one atom of that element is considered as its valency. We can say easily, we can understand this by taking one example. In methane molecule, one atom of carbon combines with four atoms of hydrogen. So the valency of carbon is considered as 4. Because as we said here, in terms of hydrogen, the valency is defined as the number of hydrogen atoms combining with one atom of an element is defined as the valency of its that element, particular element. So here, the carbon atom is connected to 4 hydrogen atoms. So one atom of carbon combining with 4 atoms of hydrogen, so the valency of carbon is considered as 4. If you see water molecule formation, in the water molecule formation, one atom of oxygen combines with 2 atoms of hydrogen. As we know, the formula of water as H2O means 2 atoms of hydrogen combines with 1 atom of oxygen. Hence, the valency of oxygen is termed as 2 now. In this way, valency is defined in terms of hydrogen. Since all atoms do not combine with the hydrogen, so the valency of the element is also defined in terms of other elements like oxygen and chlorine. Yes, here we are defining the valency of an element in terms of hydrogen. But we know all the elements may not react with the hydrogen. Then in that case, the valency of that element we cannot predict by in terms of hydrogen. For that purpose, the different ways are used here. The valencies of elements are also derived in terms of oxygen as well as chlorine also. Let us say in terms of oxygen now. Valence in terms of oxygen. Since the valency of oxygen is 2, because we told already in formation of water molecule, one atom of oxygen combining with 2 atoms of hydrogen. So the number of hydrogen atoms combining with one atom of an element is considered as its valency. So the valency of hydrogen is considered now 2. As it is known, the valency of oxygen, the valency of the combining element with oxygen can be predicted now here. That is defined as double the number of oxygen atoms with which one atom of an element can combine is called its valency. So how many number of oxygen atoms combining with one atom of an element? That number, if it is multiplied with 2, the valency of that element is obtained. Let us see this clearly with an example. In calcium oxide, one atom of calcium combining with one atom of oxygen. So the valency of calcium becomes now 2, because what we told here, double the number of oxygen atoms combining with one atom of an element is known as its valency. Double the number means here one atom of calcium combining with one atom of oxygen. So that 1 is multiplied with 2 to give the valency of that particular element, calcium. Now valency of calcium becomes now 2. For example, if we take Na2O, there are 2 sodium atoms combining with 1 oxygen atom. If you say 1 of sodium atom combining with half oxygen atom, so if you multiply this half with 2, then we get 1. So the valency of sodium becomes 1. In this way, then the double the number of oxygen atoms combining with one atom of an element is known as its valency. In terms of oxygen, in this way it can be defined. Now we see here valency in terms of chlorine. Valency also can be defined as the number of chlorine atoms with which one atom of an element can combine. Because the valency of chlorine is 1, the number of atoms that combining with one atom of chlorine is taken as valency of that element. Because how it is known here, the valency of chlorine as 1, we can see here hydrogen chloride molecule. In this molecule, one atom of chlorine combining with one atom of hydrogen. In terms of hydrogen, already we have seen the number of atoms combining with the number of hydrogen atoms combining with one atom of an element is known as its valency. So here one atom of chlorine combining with one atom of hydrogen combining with one atom of chlorine. So the valency of chlorine is taken as 1. So that by taking this as standard, the valencies of other elements which are combining with chlorine are known. Let us see here for that example. For example, sodium chloride. One atom of sodium combines with one atom of chlorine, so the valency of sodium is 1. So here sodium combining with one chlorine atom, so sodium valency is taken as 1. So what are assumptions in finding the valency? So what are the assumptions to be considered? What are the points to be considered while finding the valency of an element? The valency of hydrogen and all the metals is considered positive valency. The valency of all non-metals except hydrogen is considered as negative. So of course, for even hydrogen is a non-metal, its valency is considered as a positive mostly. As a molecule of a compound is electrically neutral, it is assumed that total positive valency in its molecule is equal to total negative valency. By assuming this, the valency of an unknown element present in the molecule can be predicted. Next, variable valency. An element with more than one valency is called as variable valent elements. In the name itself, it is a variable. Means an element can vary its valency. Some elements are there like this. They can change their valency based upon the type of compound it forms. So those kind of elements are called variable valent elements. And that valencies are known as variable valencies. And that element is called variable valent element. It has been found that certain metals exhibit more than one valency. In such a situation, metals are said to be exhibiting variable valencies. How to name an element with two different valencies? First, before that, let us see why elements exhibit variable valencies. This doubt we may get, because based upon the valence electrons element, generally they form valence, exhibit valency to become stable. That we are going to learn further. Some elements they are having incompleteness in their outermost shell as well as their last but one shell, which is called penultimate shell. The elements present in the valency shells at some time they participate in the chemical bond formation, so they show one kind of valency. Sometimes the elements in the last shell as well as last but one shell, these all will participate in the chemical bond formation, so they may show different valency. So in this way, elements they are exhibiting more than one valencies. These elements they are exhibiting more than one valency are called variable valent elements. Now, how to name an element with two different valencies? If an element exhibits two different valencies, then suffix us, us is attached at the end of the name of that metal as for the lower valency, and and suffix ic is attached at the end of the name of the metal with a higher valency. This we see here with example. For example, iron can exhibit two valencies plus 2 and plus 3. As we know, the name of iron in the Latin as ferrum. So now ferrous, OUS, by eliminating one or two letters from its name ferrum, OUS, us is attached to the ferrum, so it becomes ferrous for the lower valency plus 2. So Fe plus 2 ion is called now ferrous ion. In the same time, Fe plus 3 higher valency ion is called as by attaching ICEK at the end of its name, by eliminating one or two letters from its original name. From the ferrum, UM is eliminated, ICEK is attached. So it becomes ferric. So Fe plus 3 ion is known as ferric ion. So this is about variable valency. In the same way, some other elements are there. Copper. Copper can show two valencies, Fe plus and Fe plus 2. Now here, sorry, Cu plus 2. Here Cu plus is known as cuprous ion because the Latin name of copper is cuprum. So from the cuprum, last two letters Um are eliminated, OUS is attached. Cuprous. Cu plus ion is called cuprous, and Cu plus 2 ion is called cupric. So in this way, different names are given for the elements which are showing more than one valency. Now, based upon these concepts, what we have seen till now, let us examine ourselves by taking some simple questions. The branch of chemistry that deals with the study of carbon compounds is, here are the options. Yeah, can anyone guess the answer for this? What is the branch of chemistry that deals with the chemistry of carbon and its compounds? What do you call this? You can give answer in the live chat. Exactly, Ramesh sir. It is organic chemistry. Yeah, the branch of chemistry that deals with the chemistry of carbon is called organic chemistry. We have a special branch for studying of this carbon and its compounds because carbon can form numerous of compounds because of its some peculiar properties like multiple bond formation, catenation, allotropy, and existence of functional groups. Because of these all special properties, carbon can form so many compounds, numerous. So how many number of compounds are there formed by other elements? Total number of other elements will be equal to the only carbon compounds. Those many element compounds are formed by carbon because of its peculiar properties. That is why the study of carbon specially kept as one branch, which is called as organic chemistry. So C is correct answer, sir. Now second question. The shorthand sign for the full name of an element. What we can say? Let us see the options also. So we can simply answer this question. The shorthand sign for the full name of an element is any answers? Yes, correct. Many of you given correct answer. It is a symbol. Next question, let us see. Element sodium has its symbol as we told, sodium has its symbol from its Latin name. That is, what is the Latin name for the sodium? It is a natrium. So the symbol for sodium is taken from its Latin name natrium as. Any guess? Yes, exactly. It is D is correct answer. Na, because in the natrium the first letter is N. N is taken, but Na is already given as is a symbol for some other element nitrogen. So to avoid the confusion, along with N, one more letter from its name is taken. We are not telling the second letter always. We should say second prominent letter is taken. Of course, in case of sodium, second letter A is taken, but in some cases, always second letter is not taken into the symbol. For example, if we take magnesium, first letter M is taken. M is a symbol for there as a symbol for many other elements. So to avoid confusion, along with M, some second it is not second letter. It is taken second prominent letter. G is taken, but in the name of magnesium, A is second letter, but A is not taken. G is taken. That we say second prominent letter. While pronouncing after M, we pronounce G. Meg. G is pronounced. So G is taken into its symbol. Mg symbol for magnesium. So here, anyhow, here correct answer is D. Sodium symbol is Na. Now let us see one more question. The number of atoms present in one molecule of an element is called its. Yes, we have just now seen. Yeah, any guess here also? The number of atoms present in one molecule of an element is called its. Is it valency or atomic number or atomic mass or atomicity? Yeah, it is. Yes, It is atomicity, not the valency. Some of you are guessing as valency, but it is atomicity. Combining capacity means valency, but the number of atoms present in one molecule is atomicity. So atomicity is correct answer for this. A. Next question: a diatomic element among the following. Diatomic means the element should have two atoms in its molecule. If you see here, copper is a metal which is a monoatomic. Any guess for this also? Silver is also a metal which is considered as a monoatomic. If you see helium, yes, it is D is correct answer. Helium is a noble element which is also a monoatomic. Now hydrogen, no, some of you are guessing as copper. Copper is wrong. It is a monoatomic. Hydrogen is correct answer because hydrogen is non-metal in which one molecule contains two atoms. So H2 is A. So D is correct answer. Yes. Some they have answered C or B. They are all wrong. Only D is correct answer. Next one, the valency of calcium in calcium oxide. So in terms of as it is combined with oxygen, the valency of calcium is considered in terms of oxygen. Double the number of oxygen atoms with which an atom of an element combined is considered as its valency. Here, in this one atom of calcium combined with one oxygen atom. So 1 into 2 is considered as the valency of calcium. So here correct answer, any guessing? Some they are given 3, B, no, it is 2. C is correct answer because valency of calcium is 2 because here each calcium atom is combining with one oxygen atom. Double the number of oxygen atoms is considered as its valency. So one oxygen atom, double the number means it becomes 2. So 2 is the valency of calcium. So this is about introduction of language of chemistry. So thank you for watching our video. Please subscribe our channel and press the bell icon so that you can receive the latest updates on these live sessions through our YouTube directly to your mobile. Thank you.